Okay, so we can assume when we're finding, well, first of all, I should tell you the objective of the lesson is to factor sums and differences of powers. And we're going to be looking like at third roots, sixth roots, stuff like that, okay? These are more complex. Okay, so to find the third cubed root of 64, we need to assume that this is our polynomial, x to the third minus 64, okay? We know that 4 to the third power happens to be 64, okay? So we can assume that x minus 4 is a factor, okay? Yep, 4 to the third power equals 64. Okay, so that being the case, I'm going to find the other roots, or the other factors. So I'm going to put this right here, and I'm going to divide that into my original x to the third minus 64. But notice, I'm going to put in what was missing in between those two terms. So plus 0x squared plus 0x minus 64. Okay? Okay, so x goes into x to the third how many times? X squared. Okay. And then this is x squared minus 4x. Okay, so remember, we're going to change our signs and add them together. So this becomes a negative.
4x squared.
Thank you. And this becomes a positive. Okay, so this cancels out. We have 4x squared. Now I can bring down the 0. Okay, so how many times is x going to 4x squared?
Plus 4x.
Okay, good. So 4x times x is 4x squared. And 4x times negative 4.
16x.
Okay, now remember we're changing our signs. So this becomes a negative, this becomes a positive. Okay, this cancels. I now have 16x minus 64. 4x squared minus 4 plus a negative 4x squared is 0, right? Okay, so how many times is x going to 16x?
16.
So this becomes a plus 16. And then we end up with 16x minus 64. And that all cancels out to be 0. Okay? So, as of now, I know that my factors are x plus 4, or sorry, x minus 4. And x squared plus 4x plus 16. Okay? I need to find the other two factors. I've got it down now to a trinomial. What can I use to factor this down?
You need 2 other factors. You only need 3.
Right. I only have, but this isn't to factor down all the way.
Oh, you only need 1.
I can use the quadratic. So what's my a, what's my b, and what's my
A
c?
is 1, B is 4, C is 16.
Okay? So this will be minus 4 plus or minus square root of 4 squared.
Oh,
Okay. Minus 4 times 1 times 16 all over 2a, which happens just to be 2. Okay. Now, if I were to calculate this out, the discriminant itself, in my calculator, I would end up with square root of negative 48. Okay? So think about it. What goes into 48?
I.
Yeah, we're going to take an I out for sure. But what else goes in?
6 and 8.
6 and 8. And what goes into 6?
3 and 2.
2 and 3. And
4.
2 and 4. And then 2 and 2. Okay? So in other words, I have 2, 2, 2, 2, and a 3. I can take out 2 2's, right?
You have 4.
Mm-hmm.
4i.
So this will be negative 4 plus or minus 4i square root of 3. over
so
2.
If you had like 2 3s, then you would do 3 times 3.
Yep.
And 9. Then you have 9.
Yep.
Wait, how'd you get 4 2s in 1?
Because if I break down this 48 all the way down to its prime factorization, I get a 2 here, a 3 here, 1, 2, 3. So there's 1, 2, 3, 4 2s and 1 3.
And how'd you get to 4i?
See, so I took out a 2 from here. That comes out. And I took out a 2 from here. What's 2 times 2? 4. So that's how I got a 4 out of there. Yeah, and on the I right here. Yep.
Why would you only times 2 or something?
You're only taking it, the one representative of each pair out of the square root. Because it's kind of like saying, think about this. This is 16. What's the square root of 16? So I'm taking a 4 out of the square root. Okay? Okay, so now I can, on the top, I can take a 2 out. So I'm left with negative 2 plus or minus square root of 2i square root of 3 over 2. And guess what happens to my 2's there? Yeah. So I'm just left with negative 2 plus or minus 2i square root of 3. Okay? So that's my other two factors, is this one and the 4. Okay? All right, so one thing you need to know is this is probably the most important thing you need to know for this entire lesson.
Wait, I'm sorry, what does that answer mean and why did you do all that?
There's 3 factors. We got 4, negative 2 plus 2i square root of 3, and negative 2 minus 2i square root of 3. Those are my 3 zeros.
What about x squared plus y squared?
Yeah.
These two, if I multiplied them back together, would be that. Okay? This isn't factored all the way down yet.
And the 3 cubed roots of 64, what does that even, I don't know how to start this.
Okay, all it said was find the 3 cubed roots of 64. The first one was easy to find because 4.
What are 3 cubed roots?
How did you find 4?
Yeah.
I just knew.
How do you know?
Okay, so here's what you need to do maybe on this particular assignment today. Go down the side. Go 1, 2, 3, 4, 5, all the way up to 10, okay? Do that right now.
1, 3, 5.
I have a reason for it, trust me. 7, 8, 9, and then go to the cube. So 1 to the third is 1. 2 to the third is 8. 3 to the third is 27. 4 to the third, 64. 5 to the third, and so on, okay? So find all your cubes so that, because that way you'll recognize them while you're doing your homework. You can find your perfect cubes. Okay? I just happen to know them up through 5. I don't even know what 6 is to the third, but will I tell you? Here, you want me to look it up right now? 6 to the third is 216. What's 7 to the third?
342.
Thank you. 343. 8 to the third.
512.
Okay, and 9 to the third.
729.
Good. What's 10 to the third? Yay. Good job. Okay. All right, so you can refer to those numbers today while you're doing this. That'll help. Okay, this next one says factor 27a to the third minus 8b to the 6th over a set of polynomials with integer coefficients. So we are going to use this little formula here. This is important for your little tree diagram. You may want to use this formula, hint, hint, as one of your little branches. Okay? Okay, so we're going to factor this, and I'm going to use one of these 2 formulas. I'm going to use the bottom one because it's a minus. Okay? So the first thing I want to do is find out what the cubed root of 27a third is. What is that? 3. So 3a to the third happens to equal 27a to the third, right? Okay, how about 8b to the 6th? What is the third root of that? Yep, 2b squared to the third happens to equal 8b to the 6th. Okay, so now we've already found our factors of this.
Whoa, 2b squared to
Third.
And then if you cube that, you get
B to the 6. Yep. Okay, so my first part of this is x minus y. So I'm going to have my x value is 3a minus 2b squared. Because this is my x value here, this is my y value here.
How do you know that? Wait, how do you know to put like 2b third to the third?
Because I need to have the third root of whatever my y value is here. Because the cubed root of 8 is 2. Okay. So now I have this, and then I'm going to do the second part. This is, I'm going to have x squared. So I'm just going to put it in parentheses. 3a squared plus 3a to the 6th. 2b squared to the 3rd.
Yeah, your 2's look like 7s.
I'm sorry.
Like a lot of the time. 7s have a line on it.
Yep.
Or 2, that was like this. It happens a lot. Are you angry? Is that a 13? Yes, I am.
No, that's a parentheses.
Oh, there's only one.
Okay.
Oh, and I still wrote 13.
So notice, this is my x squared value. This is my x times y. This is my y squared value.
Can you explain all this that you're doing? Not the first part, just the second part that you started. Are you recording?
Oh, let's just simplify this out. We have 3a minus 2b squared still. But what is 3a to the 2nd? 9a squared. Okay. What is 3a times 2b? Nope. What's 3 times 2? 6ab. Okay, and what's 2b to the 2nd? Oh, you're right. That should be a b squared right there. And this should be a b squared here. So this will be 4b to the 4th.
What did you just, wait, where did all of b squared go?
That was my, right here. This was my y right here.
9a squared. Carry y squared at once.
Okay, so we're going to do this one. We're going to use the formula of x plus y and then x squared minus xy plus y squared for this one. Okay? So in this case, my x value is just x. Right? What's the third root of x to the 3rd? Okay?
Why do you know that?
Because 3 divided by 3 is x to the 1.
No, but why you know?
If I x times x is the third.
No, not that. Never mind.
Okay, so now my y value is a little goofy because there is not a nice clean third root of 10.
Wait. Is that equal sign for x?
Yes, x equals x.
Just do cube root of 10.
Yep, you're going to do a cubed root like this of 10. So now we're going to replace all of our x's and y's in our formula. Okay? So we have x plus the cubed root of 10. Okay, and then inside the x squared, we're going to have an x to the 2nd power.
Huh?
Because
You're following the formula.
I'm following the formula. I'm just placing it in. Uh-huh, you can.
Is that, you just added more times?
Yeah. Because if it were something else, I would have something else in here too. So, okay, so then this was x times third root of 10. Good question, because this one is an x to the 3rd plus 10, and if you go back to the formula up here, notice that if it starts with a plus, it has a minus. Okay? Really important to notice that. I'm glad you did. I just follow the order that they gave us. So this one I make x, this one I make y. Okay? Sure. So what do you guys think the last one would be? Third root of 10 to the what? Second power. Good.
No, because
It's still a third root.
So isn't that just the square root?
Yeah, isn't it?
Nope.
Like
no.
cubic
Oh, the
number.
square root is 2.
Yeah. So let me show you what happens to that, actually. It's kind of interesting.
Doesn't it just go to 10?
So, yeah, the squared the squared button. The squared goes actually is referring to the 10 on the inside. So what does that become? 100. Yeah. So this is going to be plus the third root of 100. Okay. If I simplify that out, this one is just x third root of 10, right? And this one's just x squared. The reason I put those parentheses in is to remind you you're putting it back into a formula. That for me is just, it helps me to remember, because sometimes you may not have a perfect clean x. You might have like,
Why are you going in all different orders? I'm so confused.
all right, so now they're wanting us to factor 1027 by recognizing that 10 to the third plus 3 to the third is 1027. So once again, if we use x is our 10, y is our 3. We're going to use that formula x plus y times x squared minus xy plus y squared. So let's just replace our x's and y's here. First one's going to be what? 10 plus 3, and then the inside is going to be 10 squared minus 10 times 3 plus 3 squared, right? Mm-hmm. What's 10 plus 3? 13. Okay. 10 squared is 100 minus 30 plus 9.
So we can actually
30 is 10 times 3 is 30. 3 squared is 9. Okay?
79
So, yep, 13 times 79. That's it.
equals what?
Equals 1027.
That was basically a proof. You just had to prove it. So what would the answer of that be?
Huh?
What would the answer be?
Well, it asked us by finding some factors, and these are both prime numbers. These are the prime factorization of it. Yeah. Yep. Okay, so now we're going to do the same thing for 973. We're recognizing that 973 is the same thing as 10 to the third minus 3 to the third. Okay, so what's my x value on this? 10. What's my y value on this?
Can we do this on our own?
Yep, try it. Go ahead, try it on your own. I'm just going to call it 3. Because you're going to use the other formula, the minus formula, okay? Okay, so this one ends up being 7 times 139 once you put it in the formula. Okay, so moving on. Now we get into a this is mean?
Yeah. I tried doing it. It's so mean.
Okay, I'm going to do the first one, and then I want you guys to figure out the second one. Just look at the pattern. Look at the pattern, okay? So this, yes. So this one's going to be, shh, listen, please. This is the same thing as saying A plus B. That's the first one. You should be able to at least get that, okay? Then you're going to have A to the 6th minus A to the 5th, B to the 1st, plus A to the 4th, B to the 2nd, minus A to the 3rd, B to the 3rd, plus A to the 2nd, B to the 4th. Look at the pattern. Look at the pattern. Minus A to the 1st, B to the 5th.
Where are these coming from?
Okay, so it's pretty much, it's just inverted.
So this one, notice that we are x to the 6th and minus 64, okay? I'm going to tell you something. There's a little trick here. x to the 6th is the same thing as x to the 3rd to the 2nd power, right? And 64 is the same thing as saying 2 to the 3rd power to the 2nd. Okay? So I'm going to use the difference of squares. We're going to do the conjugate thing for this. Okay? So I have x to the 3rd minus 2 to the 3rd and x to the 3rd plus 2 to the 3rd. Okay?
Why did you do that?
Because you can square them.
Yep. Yep, so then that equals this.
Oh,
Yes.
Okay? So now we can use our difference of cubes and our addition of cubes, sum of cubes for both of these. Okay? So now this is going to be x minus 2 as my opening.
So wait, just like looking at that, how do we know, oh, I can use difference of squares?
Yeah, that's the hard part.
Yeah.
Okay, so this one's a tricky one, and I'm just making you aware that you might want to think about this might be a possibility so that you have a
But
chance
what
of
if we
doing
do
it.
the whole problem, right?
Mhm.
It's not a possibility. You and that is
Okay, so this will be x squared. What's my middle term on this, you guys? What's my middle term?
It's 2x.
Yep, it's a 2x. Okay, and then what's my last term on this one?
Plus x.
X.
No.
Yep. Nope.
2 squared.
2 squared, which is what?
Where are you getting?
4. I'm putting it back into our formula, remember?
Wait, where'd you get 2 squared?
Because you do x squared. Which is the second section.
Wait, x squared.
Yeah.
Okay, so you guys remember that my x is x, my y is a 2.
How did you know that your x was a... How do you know that? Oh my god. Where did you pull your x?
All right, so now I've broken this down using our difference of cubes. I'm going to break this down using our sum of cubes right here. Our y value is 2, our x value is x. So this would be x plus 2. I'm going to put those values into this. So I have x squared minus 2x plus 4. Okay, so m to the 4th is the same thing as saying m squared to the 2nd, right? And 81n to the 4th is the same thing as saying 9n squared to the 2nd. So these are a difference in squares again. I can conjugate this. So this will be m squared minus 9n squared.
That too looks like 7.
Oh, sorry. Okay. Okay, and then this is going to be m squared.
Is that a 2 on the 9 end?
Yeah, it's a 2.
It looks like a little poodle.
It's a poodle. There. Okay, plus 9n squared. And I can reduce this one. This is still a perfect square. What's the square root of m squared? M. What's the square root of 9n squared? Now I'm done.
Why did you write it?
I'm done.
No, what? No, you didn't. What?
I did the same thing. I took the square root.
Huh? Why are there 3 sets of... Where did that last set of parentheses
It
go?
came from this.
No, the last one.
This one, that's just that same one.
Then why do you have 2 of them?
This one is the difference of squares. You do another one. What's the
I don't know
square?
what the difference is. I don't know what that
Remember, we did that the other day. Remember? So if I have x squared minus 9, how do I factor that?
means. Absolutely no clue.
You take the square root of them. Conjugate. So it'll be x plus 3 and x minus 3.
Not my brain.